Welcome to Spring LIB.
This is the answer to Chapter 11, problem number 67 from the Smith Organic Chemistry textbook. And here we're asked to draw a stepwise mechanism for this intramolecular reaction. So we're going from one ring to two rings, and we have an alkyne and an alcohol and a double bond inside the ring. And the double bond inside the ring actually isn't going to do anything. And so this is going to be a reaction featuring the alcohol and the alkyne. And so we have formic acid here. And the first step in this reaction is going to be formic acid protonating this alcohol. So that's going to look like this. So we now have the protonated alcohol here. Okay. And so this carbon-oxygen bond can break, and the H2O here can leave as water. Oops. And so we now have a carbocation here, and the electrons in the alkyne can act as a nucleophile. These electrons can shift over here to the carbocation. And so that's going to be how we form our second five-membered ring here. And so we now have a fused bicyclic ring system. So these two rings still have our double bond there, and now have this here. Okay, and we'll have a carbocation on this carbon. And so there's water in this system, and the water is going to add to that carbocation. So like this. So now, after that, we have this product. So there's a positive charge and only one lone pair on the oxygen here. And so we can use that formate ion from the first step. So this guy's still floating around. Negative charge there. You can come and grab a proton. And after that happens, we will be in an enol form. I'm actually going to move this a little bit. Okay, so as I said, we'll have the enol here. And so from the enol, we can essentially just tautomerize, but the actual mechanism for that is going to look like this. So we have formic acid again. The electrons of this double bond will grab a proton and become protonated. And so we will be here. With a carbocation here. And these electrons can go here to form the new carbon-oxygen double bond. Oops, that was wrong. Okay, so carbon-oxygen double bond. The oxygen is going to have a positive charge and one lone pair. And so now all that has to happen is we could say water, or we could say the conjugate base of that formic acid. So the formate ion again can come, grab this proton. These electrons can go like that. And then that's it. That gets us to our final product here. Okay, so there it is. That's the stepwise mechanism for this reaction. Yeah, so it's a protonation, water leaving, the alkyne acting as a nucleophile and adding to that carbocation to form the second ring, and then water adding to the carbon. That's the new location of the carbocation. That added water is deprotonated, and that's basically the enol. And then we just tautomerize from the enol to the ketone. And that's the answer. And that's the answer to chapter 11, problem number 6.